Hey everybody. Today we're getting into the indefinite integral. This won't take us long at all. Let's go. So we often run into problems where we need the most general antiderivative of a function, but so far we don't have notation for that. Let's fix that. So we're going to write integral f of x dx just to mean the most general antiderivative of f of x. The notation's inspired, of course, by the definite integral, and in particular by the second fundamental theorem of calculus, which says we can evaluate a definite integral by finding an antiderivative, then plugging in values and subtracting. You do have to be a little careful. The notations are very similar, and you're going to be finding antiderivatives in each case, but the results are going to be very different sorts of objects. The definite integral gives you back a number, while the indefinite integral gives you back an entire family of functions. So you've really got to keep that fact straight. Let's do a couple of examples. First of all, integral x minus 2 4 minus x squared dx. So when we're doing an indefinite integral, we're asking for the most general antiderivative. So how are we going to get the most general antiderivative of this function? FOIL things out, and then for each term in that polynomial, raise up the power, multiply by the reciprocal of that power. Overall, negative 1/4 x to the fourth plus 2/3 x to the third plus 2x squared minus 8x plus c. Problem 2. Integral secant 2x tangent 2x dx. So we need the most general antiderivative of secant 2x tangent 2x. Hopefully we remember that the derivative of secant theta is secant theta tangent theta. So here we expect an answer like secant of 2x. But if we differentiate secant of 2x, we get secant of 2x tangent of 2x times 2 by the chain rule. So an extra factor of 2 that we don't want. We need to make sure that that cancels. So we're going to include a factor of 1/2 in our antiderivative. Overall, 1/2 secant 2x plus c. Notice in each of these cases, I was careful to include the plus c at the end of my antiderivative because I need the most general antiderivative to do an indefinite integral.